Okay, so I wanted to talk about adding vectors algebraically. First of all, it's super easy when you're adding algebraically. You're just going to add the first values of each vector. So this is called our x sub 1, and this is our x sub 2. So you're just adding those together. So if I'm going to add vector v plus vector s, that's just going to be taking the 3 and the negative 2 and adding that together. So that's 1. And then if I'm adding the y sub 2's, so this is y sub 2, y sub 1, and this is y sub 2. So my first y, my second y. So when I add negative 6 and negative 1, that just adds up to negative 7. So to add two vectors, you're just adding the first values together and the second values together. So this is be the resultant vector. So sometimes you'll see the resultant vector as the r. Pictorially, if you're going to graph the vectors and add them together, so if I'm looking at the x and y axis, and I'm going to graph vector v, so 3, negative 6, so it's to the right 3, down 6. So if I count over 1, 2, 3, down 2, 4, 6, this is where vector v is going to end. So I'm going to label that as v. S is going to be to the left 2 and down 1. So that's going to be the left 2, down 1. This is where vector S is going to end. So I'm going to draw an arrow there. Call that vector S. All right, so if you're using the parallelogram method, basically what you're going to do is take your two vectors that you have and make a parallelogram, complete the parallelogram. So if this side right here has a slope of up 1 over 2, I'm going to do the same thing. So go from your origin to the end point. You're going to go down 1 to the left 2. I'm going to do the same thing from this end and create this other side. So if I am trying to create the side over here that's parallel to S, I would go down 1 and over 2. And that would be the side that's parallel to the side that's marked vector S. And then if I connect these two, this will make the parallelogram. I have the four sides of my parallelogram. All right, wherever these two sides end, that's going to be your resultant vector or your answer. So let me make that darker. So this is my resultant. This is my answer. Notice that it's the same as my numbers that I had up here where I had 1, negative 7. So if I go to the right 1, down 7, I've got the end of this vector. So graphically, you can see that you're getting the same answer. It's 1, negative 7. So this is called the parallelogram method. You can also do the tip to tail method on this. So if I were to graph, again, these two vectors, and my first one is 3, negative 6, so I'm going to the right 3, down 6, 2, 4, 6. My first vector v is going to end here at this point. When I do the tip to tail method, so vector v, it ends here. I'm going to start from here, pretend like this is my origin, and just add on vector s on the tail. So on s, I'm to move to the left 2 and down 1. So from here, go to the left 2 and down 1, and I would end right here. So on the tip of my first vector, I just started the next vector, vector s. Wherever this vector ends is going to be your resultant vector. So if you notice that from here back to where I started from originally, this is my resultant vector r, which is also positive 1, negative 7. So you're getting the same answer, whether it is algebraically or pictorially with the parallelogram method or the tip to tail method.